So I don't know that the nanobots would shield anything. But in any case, I think this is wrong, and even Kurzweil will admit there's a problem with this, because if you're a thinking machine, you don't want to distribute your processing through all these nanobots. Right? Not that distributed processing is a bad idea, but now you've got the time of flight delay. You know, that nanobot over there wants to ask a question or wants to be updated or whatever, and he's 10 feet away, so that takes 10 nanoseconds to get the signal back to you, and another 10 nanoseconds for you to get the update back to him, right? So you don't want to do that. What you really want to do is hunker down into a little glob of computronium, whatever that is, right? Which is sort of the maximum density material that can compute. You want to keep everything very tight because you're stuck with this. You're stuck with the speed of light for a lot of operations. Okay, so it seems to me that what you're going to get is, in fact, some sort of computing machinery that's very dense, localized, because that's the best machine. Okay, and you can say, well, would there be lots of machines? There might be, but if there's only a slight difference in the rate of improvement of any of the machines, then there's going to be a winner-take-all situation. Whatever machine gets ahead will stay ahead indefinitely, okay? Now, where would they go? I don't know. I mean, why would they be on planets like the Earth? They don't need nice atmospheres and liquid water. They just need energy and matter. And one nice place to get both is at black holes. This is a scheme, I guess Roger Penrose had this idea. You just throw your garbage out when you orbit a black hole and you get all this energy out. You can get a lot of energy out of a black hole. So, you know, maybe that's a place where this machine would hang out. Another possibility that has been suggested by an astronomer from Eastern Europe is that the machinery would all go to the edge of the galaxy, because that's where it's coldest. And those of you who still remember sophomore thermodynamics know that a machine's efficiency depends on the difference in temperature between the temperature that the machine is operating and the heat sink, the environment. Right? If there's no difference or very little difference, it's not very effective. And that's why, you know, cruise lines can't operate their ships on the basis of the heat in the ocean, right? Because there's no heat sink nearby that's substantially cooler. So he thinks that all the intelligence is going to be around the edges. Well, that makes sense thermodynamically, but it seems to me that would be really dull. But I don't know what's dull for thinking machines. I don't know. This strikes me as an obvious location. This is the center of our galaxy, as seen in infrared. And as you know, the center of our galaxy is where all the action is, right? The density of stars, even near the center, is 1,000,000 times greater than it is here. There's a lot of radiation, there's a lot of matter. So there's energy and matter, which is what counts for a machine. It's just proof of this is a black hole, supermassive black hole seen in another galaxy. So let me just sum up by saying, look, we've come a long way in 4 billion years, mostly based on things like DNA molecules. We've gone from life to the Cambrian explosion to us. Okay, and that's taken 4 billion years. But it's not going to take very much longer to go to the next step. And that might be a very long-lived step, and that might be the commonplace step. So my suggestion is that our destiny may, in fact, be down here, but that this might be worth some thought in terms of our SETI experiments. Because if we look only for Earth-like worlds around Sun-like stars, or some analog of that, then we may be looking for the kind of intelligence that is in fact very, very short-lived. And we might do better to look for the very long-lived intelligence, which is the result of deliberate engineering. Okay, thank you very much.
Bravo. Bravo.
Time for questions?
I'll explain one.
Anybody have it? Yes, sir.
Yeah, hi. Did SETI develop a protocol for, like, if they do ever, well, when they make contact with someone, do they have a protocol for, like, are they going to investigate, immediately respond or contact them, like find out like what they're about?
Yeah, the question concerns protocol. What happens if you pick up a signal? Actually, that is an endless source of discussion at the meetings of the International Academy of Astronautics SETI Permanent Study Group, which Tom mentioned. I happen to be the chair of that. We're having another meeting coming up in about 4 or 5 weeks, actually, at these annual meetings. And what is the protocol? We're trying to change the protocols. There are some protocols left over from the time in which the Soviet Union and the US were both doing SETI. And they tend to reflect the politics of that era. We're trying to simplify them, and this is what we want them to say. If you find a signal, by the way, there's no force of law here. This is just a gentleman's agreement. There's no law governing what we do if we were to find a signal. But this is what we say we would do, and we try to get other SETI experiments to sign on. If you find a signal, first thing to do is confirm it. You want to make sure it's truly an extraterrestrial signal, not get everybody all hepped up about something that turns out to be interference. Second thing, you notify the astronomical community. You want as many astronomers around the world to look at this as possible, because whatever star system you're looking at or whatever it is might set, and you want to be able to follow that star on the other side of the world. You want to collect data of all sorts. Okay, so you notify the astronomers, you notify the press, you notify the government. There's no particular order there. Our experience with false alarms, and to be honest, I described this in the first chapter of my book, because we've had false alarms. We know what happens. The first people to know are the media, which means you are the second people to know. But long before the government, by the way. I suppose the government will find out about it on CNN. And the third part of the protocol, so you notify everybody. The third part of the protocol, it says no response without international consultation. In other words, no organized response without talking to a lot of people. So the real purpose of that isn't to forestall responses. We've already been responding in some sense anyhow with our radars and our television for years and years. So. But the idea here is to reassure the world that if, for example, it's an American experiment that finds ET, that it isn't just the Americans that are in touch with ET. Right? That's an unfounded fear, but it is a concern some might have. So the idea is to dispel that by saying, look, if we're going to send a deliberate signal to that star system or whatever it is, everybody will be involved. Yes, ma'am.
Assuming that maybe, they have a different kind of way of communication, and, with our 100 or 50 years of radio communication, so let's say, whatever, but there is intelligent life there, like there was 150 years ago, let's say, on Earth. So how are we with all the transiting of planets and everything, to eventually, like with Kepler, to be able to understand the atmosphere or the spectra of the atmosphere of another planet? Where are we being able to deduce, well, there is similar life to what there is on Earth on that planet, but maybe they don't happen to have radio telescopes?
Yeah. Could everybody hear the question? Could you hear that? Yeah. Okay. Then I won't repeat. Well, look, the search for life beyond Earth, not just intelligent life, there's kind of a three-pronged search. The bottom line is simple. We still haven't found compelling evidence for any life beyond Earth. Okay. But there are three approaches to finding it, and if you were to ask me to bet, I would bet that one of them may pay off within 20 years. Right? One is obviously SETI. I've already talked about that. The second is to simply brute force, go to these worlds and explore. We can do that in the case of Mars. We can do that in case of some of the moons of the outer solar system. There's tremendous interest to go, for example, to Europa around Jupiter, right? and drill down. Just melt your way a hole through the 10-mile thick ice there, and presumably get to the water underneath, and sample that. Okay, and these are all the programs that NASA and other space agencies have looked at, and they know how to do it. This is a matter of budget mostly. But within 20 years, I'm sanguine that they'll do that. So that's horse number 2 in this race. And horse number 3 is what you're alluding to, and that is to use spectroscopy to examine the light coming from extrasolar planets. Doug talked a little bit about that, but you see, Kepler doesn't have a spectroscope on board. It's just looking at the brightness of things. What you really want to do is break up that light into a spectrum and say, hey, is there oxygen, is there methane in the atmosphere of that planet? Which would be a good clue that there's some biology as well. Okay, that sort of thing. And again, that's been thought of, and there are missions planned, again, by NASA and also by the Europeans to do that with space-based telescopes. And if the budgets were bigger, those things would be flying within a few years. It may take longer now because of the staging of the budget. So that's where we are. And how fast we go depends on how quickly we can get the monies to build these instruments.
And what about all the organic molecules in space, and dust clouds in space, and stuff like that?
Well, the organic molecules in space, the dust clouds in space, you're quite right. All the ingredients for life seem to be a common concomitant to the formation of planets. When you form planets, it seems you get a lot of these organic molecules, including things like amino acids and other things, that rain down on the planets that are forming them. And if you think that those are essential to getting life started, then everybody starts with a good list of raw ingredients. I mean, that doesn't prove that there's life out there, right? I mean, I go to the pyramids in Egypt, they're made out of limestone, but it doesn't mean that every place I find a bunch of limestone, I also find pointy architecture, right? Yes, sir?